stream. Can you see that?
Yeah, it says meeting is now streaming live on YouTube.
Okay, hang on, I've got to find. Well, hi everyone, Lisa Tamati here, and very excited to have you hopefully join us this morning. It's 7:30 a.m. in the morning here in New Zealand, and where Dr. Elena Seranova is, it's very late at night. How are you doing, Dr. Elena?
Good. How are you? Happy to be here again.
Yeah, very excited for today's topic. So we're going to be doing a discussion around autophagy and NAD boosters and sirtuin genes. So it's going to be a really interesting discussion that is really beneficial for you if you want to know how to live longer, live healthier, and optimize your body and your mind and your potential. So Dr. Elena, can you just tell us briefly a little bit about yourself?
Sure. So I started my journey as a psychologist. So I'm an interdisciplinary scientist. I majored in psychology at first, and then I had my own private practice for 5 years, which turned out to be a successful wellness center. And I really got fascinated by neuroscience and the brain. And for this reason, at first I started studying the brain myself, and then I found an amazing master's degree at the University of Sheffield in translational neuroscience, which basically combined the research on neurodegeneration with with applications that could translate into therapeutics. So this is what translational neuroscience means. It's basically the combination and the outcome of the research of the hardcore biology research that can be utilized for therapeutic approaches in patients. Yeah. And I really enjoyed that. So that was quite cool, being in the lab and doing molecular biology experiments and so on. So I kind of fell in love with the lab, and I decided to do a PhD as well. And I continued my studies in autophagy and stem cell biology, and it was quite challenging, but at the same time, I really enjoyed it. And I can definitely say that science is a big part of my life.
Definitely your thing. Okay, so autophagy and stem cells. So in relation to neurodegenerative diseases in that case. Okay, but what is autophagy? Because a lot of people will be listening and go, what the heck's that big word, autophagy? It's sort of, big word in biohacking circles, but perhaps not in the general public. Can you explain what autophagy is exactly?
Yeah, sure. So autophagy is a catabolic pathway that degrades dysfunctional organelles in the cell or protein-prone aggregates. So any material that is basically unwanted in the cell, autophagy can degrade. It's like the stomach of the cell.
So it's like eating it. It's eating
yeah,
sort of.
exactly.
And
what happens when autophagy is activated? We actually have the formation of the so-called phagophore, which is a membrane structure that basically engulfs different organelles and materials that need to be degraded to form the so-called autophagosome, which is a round organelle that basically has this cargo that needs to be digested, that eventually fuses with the lysosome. And lysosome is another acidic organelle that contains acidic hydrolases that are able to digest this cargo. And this process is very essential for the cell. It's very vital. It's evolutionary conserved in multiple species, from yeast to mammals. And if it doesn't work well, the cell is basically in trouble, because you have all this garbage, floating around, and there is nothing to remove them. So this is why autophagy is important, and we have different pathways that autophagy can be activated through as well. So one of those pathways is mTOR, mammalian target of rapamycin, and then we have other pathways that can activate this this process, such as AMPK, GSK3, and so on. And
so is this like sorry to interrupt, but like, because I know the people out there might be like, whoa, that's a lot of big words and a lot of information. So is it like that the cell has to do a house cleaning, and it's got stuff inside the cell that is not working optimally and needs to be gotten rid of? Or is it the whole cell? So it's not apoptosis, so it's not where the whole cell is disintegrating.
It's actually it's a pre-apoptotic pathway. So before apoptosis is activated, we have autophagy, and if autophagy fails in what it needs to do, then we have activation of some apoptotic pathways. So it's one step before that, and if everything goes well and autophagy is functional, and by the way, in different diseases we might be having different autophagy impairments at different stages of autophagy. So it's either the initial phagophore formation, for instance, that it's not working well and it can't engulf the cargo, or it's later stages of autophagy, such as the acidic hydrolases in the lysosome that are actually not that acidic, so their pH is not acidic enough to digest the cargo. So we might be having different defects in the autophagy pathway in different diseases, and
that leads to apoptosis.
And if autophagy is not doing its work correctly, then eventually we will have apoptosis. And actually, this is what we're seeing in vitro models of neurodegenerative diseases as well. So, for instance, if autophagy is not working well, and we have, let's say, dysfunctional organelles such as dysfunctional mitochondria that are not working well. Let's say they are depolarized and they're not. And there is an excess production of reactive oxygen species going on. So if nothing can degrade these dysfunctional mitochondria, you'll keep on having this accumulation of reactive oxygen species, which eventually will lead to DNA damage and the activation of PARPs. And it's basically a death spiral that will keep on leading the cell towards death.
Okay, well, so what is a PARP? You've mentioned PARP there, and just for the listeners too, so apoptosis is basically cell death, programmed cell death. So this is not, what's the other one, necrotic or something? Necrosis. Yeah, necrosis, where the cell dies for unnatural reasons, but this is sort of a natural programmed cell death. But we only want that if we're actually renewing the cells and we're wanting new stuff. So before that, the body tries to do this autophagy process. Is that how it works? And then what is PARP? What is PARP? Because that's a word again.
So PARPs are a class of enzymes, and in order for them to function, they need a molecule called NAD, so nicotinamide adenine dinucleotide, and they're actually competing for NAD in the cell. And whenever we have increased DNA damage, we would have the PARP activation as well, and this would lead to NAD depletion, which kind of brings me to my next point about what other enzymes consume NAD. And one of those enzymes are sirtuins, which are the so-called longevity genes that are basically responsible for multiple processes in the cell, including epigenetic regulation of gene expression. So they do, because sirtuins are a class of enzymes that are also dependent on NAD, and they're also deacetylase enzymes, meaning that they remove acetyl groups from the DNA. And as a result, they control which genes will be expressed in which tissues, which is very crucial for the cellular identity and for the proper function of different cells. So sirtuins in a healthy cell, so sirtuins should be upregulated, and they should be having this housekeeping gene where housekeeping function where they basically control what's going on with the DNA repair, and also with different with the gene expression as well. And if we do start having impaired autophagy, and let's say there is increased reactive oxygen species because there are increased dysfunctional mitochondria in the cell, you will be having more activation of PARPs, and all of the NAD will start being drained from the PARP. and sirtuins will not have enough NAD to function.
Okay.
So there is actually quite an elegant interplay between autophagy, NAD, and sirtuins.
Okay. Yeah. Okay. Can I just, put that back to you so that we can slow down, because we are going quite technical quite fast. And I think a lot of people might be like, what the heck? What are they talking about? So the sirtuin genes, basically longevity genes, and then one of their jobs is DNA repair. And another of their jobs is to say which genes are actually being activated right now. And these sirtuin genes, and they're also responsible, I think, for cell replication. Is that correct?
The
Or they
sirtuin
helped.
are responsible for multiple functions, directly or indirectly. So, for instance, the sirtuin 3 gene is also responsible for mitochondrial biogenesis, and it's implicated in the amount of mitochondria that are being produced by the cell, which is related to cell replication eventually, because you do need to have enough ATP levels to replicate.
Right. Yes. And so this is definitely to do with ATP production as well, and mitochondrial health. So they're doing all of these jobs, the sirtuin genes. So they're very, very crucial genes in our genome, and these are preserved across every species, I believe, species on the planet.
Well, so from yeast to humans, it's also sirtuin genes are preserved very well.
And when things are preserved across species, then that gives a scientist an indication that this is probably a very important biological function, and we need to have a look at this one, because it's, from what I understand. Okay, so when you have activated PARP because you're not doing autophagy well and there's things going wrong, it's taking the NAD. So NAD is basically like a fuel source that both the sirtuin genes, and when PARP is activated, it's using to fuel its job. And so there's this competition for competing fuel sources. So like if you imagine you've only got one tank of fuel for your car, but you've got to go in two different directions and do two different jobs, you go, how am I going to divide up my energy? So then it becomes important as to how much NAD we have in the body. So what is NAD again? It's nicotinamide adenine dinucleotide, but what is that? And how does it work?
It does serve as a substrate for all of these enzymes, including sirtuins and PARPs, and is basically a master regulator of metabolism. So it's a very important molecule, and it serves as, without NAD, the cell is not able to function properly, just because this crucial molecule is implicated in so many different reactions. So NAD is found in all living cells and organisms. This is also evolutionary conserved across species. And it exists in two forms: NADH and NAD+, which is the reduced and the oxidized form, respectively. And both of them are important, and both of them are implicated in multiple cellular reactions. So
does it go backwards and forwards in a cycle, NADH, NAD+, by donating electrons back and forth, sort of thing?
Through the electron transport chain in the mitochondria. So this is why it's so important. And so what we're seeing now in the latest advancements in longevity research is that we actually can supplement with different precursors of NAD, such as nicotinamide mononucleotide, for instance, NMN. And this is the supplement that my company is currently.
So you've now got that available on the market because this is such a crucial thing. And
exactly. And I think that it's really interesting to also say that when it comes to the interaction between autophagy and sirtuins, there is also another regulation of autophagy there. So sirtuin 1 is actually responsible for activating some transcription factors such as TFAP and FOXO3 that have to do with initiation of the autophagic process. So for this reason, when we do have dropping levels of NAD, decreasing levels of NAD, and there is not enough NAD for sirtuins to do their job, and let's say again, let's talk about that previous example in neurodegeneration when you have increased reactive oxygen species and you have increased activity of PARP. and oxidative stress and decreased activity of sirtuins, not only the situation is already bad, but because sirtuin 1 doesn't have enough NAD to function and to activate the TFAP and the FOXO3 transcription factors to initiate autophagy, now you have all of this dysfunctional mitochondria floating around, and autophagy starts being impaired as well because it's not being activated enough. So it's a negative feedback loop, which actually accelerates this scenario where the cell is going towards the towards cell death, basically.
So that means, like, if you don't have enough NAD, then your SIRT1 gene's not going to be able to initiate autophagy and clean up the cell, and you're going to have dysfunctional mitochondria. Is that independent of the mTOR pathway, or is that am I getting confused?
Good question. So what happens is, so there are some molecules that activate sirtuin. So for instance, sirtuin 1 is activated by resveratrol, and this is something that has been demonstrated many years ago. And when you have sirtuin 1 dependent activation of autophagy, you will be having it through an mTOR independent pathway.
So it's a fasting mimetic resveratrol.
Yeah, absolutely. So because we now know that the mTOR activity is not affected by intake of resveratrol, and this is quite crucial, because actually even if we want to activate autophagy, we shouldn't do it through the mTOR pathway. This is not the preferred way, because mTOR is also responsible for growth and translation in the cell. So this is not, it's also quite a key player in the cell. So it's a serine 3-ionine kinase, and you actually don't want it to be activated at all times, because this may lead to cancer or other conditions. So what we're focusing on at the moment is to find molecules that are that can activate autophagy in an mTOR independent manner.
Okay, so if the mTOR, because mTOR is usually what's for growth, it's anabolic, it's causing growth. So for example, a bodybuilder goes to the gym, they're in an anabolic state, they are in an mTOR growth state, and when you have autophagy, that's sort of the opposite. So it's a catabolic state where it's starting to eat itself. So this is why. So with mTOR, most people do fasting for that reason, to activate the autophagy.
This is another good point there. So when we're fasting, and there's actually conflicting evidence out there as to when autophagy is fully activated.
Yes. So, how many hours it takes?
Usually people say that around 24 hours you start having the autophagy activation. There are others that swear by the ketogenic diet and say that if you don't consume any carbs, you will get the autophagy activation anyway. However, from what other researchers have found is that if you are in a ketogenic diet and you do consume meat, it depends on what kind of meat you consume that will either activate autophagy or not. And it all has to do with levels of different amino acids in the cell, because autophagy is quite sensitive to nutrients and to nutrient starvation to be activated. So if you have an abundance of amino acids, again, it will not be activated. So for instance, one amino acid that activates autophagy very well is leucine. And if you're eating certain meats that are rich in leucine, this is probably not good for your autophagic state. So this is something else to keep in mind. And I've heard, I think it was Dave Asprey saying that if you can manage to be on under 15 grams of protein per day, you will probably keep the autophagy going. So again,
but if you're going, because a lot of people on keto think I can eat a lot of protein, which is a bit of a mistake, really. It isn't about having. That's interesting, because I had Dr. David Minkoff on my podcast, Pushing the Limits, a while ago, and he has a product called Perfect Aminos, which is a really a 99% usable form of amino acids in combination. And I was interested, well, hang on, if I'm having that, which is going a lot of good things in the body, but is that going to inhibit my mTOR, autophagy, sorry? because I've got too much leucine in there, you know.
Yeah, this is a very good point for all of these processed foods as well. So, for instance, there are some ready meals you can get, or some protein bars that claim to have all of this
no carbs
acids and everything, and then they and then they slam a badge on their pack saying that it's vegan as well. But then why is it vegan if it has all the amino acids? Because that's one of the selling points when you're actually on a vegan diet, or you have some days where you are on a vegan diet. You want to get yourself in a state of partial amino acid depletion to get this beneficial effect of enhanced autophagy and recycling on intercellular toxins and so on.
Right. So for certain periods of time, you want to do this, and it's a cycling thing. You don't want to be completely deficient of aminos for too long, because then your body will start to break down.
This is what I do personally as well. So during the week, I'm usually, I am a fan of keto / carnivore diet. So this diet is quite comfortable for me, and I enjoy it quite a lot. But then during my week, I try to have some days where I'm either vegetarian or vegan, just because I want to have those benefits.
Up and down. And this seems to be a theme in biology all the time, is that, it's not one thing. It's not staying on keto forever and ever, amen. It's about doing cyclic keto or cyclic vegan or cyclic, and the body loves this push and pull and this recovery and this growth, and then cleanup phase, growth cleanup. So that's so autophagy can be activated through fasting. It can also be activated through having resveratrol and upregulating the sirtuin gene. How else can we activate autophagy?
So there are different ways. There are different things you can really implement in order to activate autophagy, and I think that it all has to do with how you build your lifestyle in general. So I think that in order for your body to function properly, you really need to have a kind of a healthy routine in general. And an analogy that I can give you there is that there are people that would buy a couple of supplements, and then they would be so proud of it, and then they would say, oh yeah, but I'm taking those supplements now and I'm so healthy, and then their biorhythms are all off, and they sleep at 5 a.m. every day, and they're eating crappy foods or super processed foods, and then
it's not going to work.
It's all good. So I think that when it comes to being healthy and activating your autophagy levels and having a healthy lifestyle in general, you need to start with the basics first. Yes. So the intermittent fasting is definitely the first step to take in order to become a bit healthier. And from the research that I'm reading and from the things that I'm implementing, I definitely believe that both anecdotal and scientific evidence point towards the fact that intermittent fasting is actually the way to go.
Yep.
And I mean, there are conflicting opinions out there, and there are pros and cons in every diet and so on. And I get that, but I personally believe that with intermittent fasting, if you try to narrow down the window where you're uptaking food, this is very, very good for you. So this is step number one.
Yep.
And then again, so either you're trying to raise your NAD levels or you're trying to activate your autophagy, because those pathways are quite intertwined. And what you eventually want to do is you want to have increased levels of sirtuin, sirtuin 1 in particular, sirtuin 3, of course, and so on. And for this reason, in order to preserve this this pool of NAD that is available for the sirtuin 1 to activate itself and activate the autophagy pathway. Another small tip that I can give is to actually avoid sunlight, which is something that people don't really consider. But what happens when we're exposed to sunlight, when our skin is exposed to sunlight for prolonged periods of time, we start getting the DNA damage. And when you get the DNA damage, you have the PARP activation, and then again your NAD pools
wow, I never connected those dots. That's really interesting. So because I mean we need sun, we need sun for vitamin D and for our mood and all of that sort of stuff. So you're not saying don't have any sun.
Yeah, sure.
But with because the sun is causing DNA damage, it's going to cause more PARP activation. It's going to have the sirtuin genes going to repair the DNA. That's going to use up the body's resources, is what you're saying.
Yeah,
Okay.
yeah,
Wow.
exactly.
Never. Yeah, that makes sense. Makes sense. You know, like yeah, and by the same token, you know, like things like smoking that breaks DNA like no tomorrow.
Yeah.
And this is why smoking ages you, is because of all the DNA breaks. And this is why when you're in the sun for hours every day, you get wrinkly skin, and you get, you know, collagen loss, and all the rest of the, you know, things that are happening. So anything that's going to be causing DNA breaks is going to cause you to age quicker.
Exactly.
Using up the resources, basically. Wow.
Yeah.
Okay.
So it's obviously, you don't have to become a vampire, and it's okay to walk in the sun, you know, when you want to go somewhere. But sunbathing for hours is definitely not something you want to do with to get your body go through, basically. So that's another tip. And then something else really simple that can be implemented on a daily basis in order to maintain your sirtuin levels, and as a result your autophagy levels and your NAD levels, is also to take a tablespoon of extra virgin olive oil, which contains oleic acid, and it basically does the same job as resveratrol. And it's quite interesting. I think that there's been a recent research article out that shows that oleic acid might even be more efficient than resveratrol in terms of activating sirtuin 1, which I think it's really cool. And
so well, combine the two. I do.
yeah, absolutely. You can do that. And then, you know, you need to make sure that the extra virgin olive oil is actually of a very good quality.
Exactly.
Because there's a bunch of, you know,
there's a bunch of rubbish out there.
Yeah.
So make sure it's, you know, from an orchard that, you know, it's cold pressed, it's all those extra virgin, it's all that sort of good stuff, and not, how do they do it with solvents and stuff, or that it's come from multiple orchards and been cut with other oils. It's a really important point. And that oleic acid does so much good things in the body. But isn't that fat, Elena? Like lots of people are like, in their minds, they're going, but oil is fat. It's the same with MCT oil. You know, there's this, you know, isn't that going to make you fat when you eat fat? There's still a bit of that around.
There are good fats and there are bad fats. Exactly. So olive oil is a good fat, MCT oil is a good fat, avocado is a good fat. So not all fats are made equal. So this is definitely something important to keep in mind, and you know, especially with a good quality extra virgin olive oil, there is,
because each one of our cells has a membrane that is a phospholipid, isn't it? So we need fats to actually this building of our cells and to the integrity.
We have a phospholipid layer in the brain as well.
Wow.
And this is why we actually supplement with omega-3 fatty acids, because this is what it does. So this is what omega-3 fatty acid do. They go into the phospholipid membrane, lipid membrane, and then they basically
make the integrity of that membrane better.
They contribute to the healthy phospholipid layer in the brain.
So that's why it's very important for neurodegeneration to have omega-3s going in. And again, people get quality omega-3s, not your cheap supermarket ones that are perhaps oxidized and been sitting on the shelves for 6 months. So really important to get a reputable source there. And omega-3s, of course, in fish as well, and krill and so on. Okay, so, but is there a downside to fats? Because, you know, I study epigenetics and a lot of people's profiles come back with don't have too many fats. And it's been one of those things in my head is like, well, why would some people not come back with, you know, you shouldn't have too much fats? I mean, there are things like gallbladders being removed. That's a pretty specific thing, but is there a genetic component? Probably not your wheelhouse really, but is there a genetic component to your ability to process fats?
There is FTO genetic component, and I've actually seen this with, you know, a family that has a history of a very problematic digestion of
fats.
fats and so on.
Yeah.
Yeah, absolutely. But yeah, again, not all fats are made the same. And when you cut off the bad fats from your life, things change and everything changes really.
Yeah, and it really is very satiating too to have a little bit of fat, and it can really help with cravings and blood sugar spikes. But getting off topic, so you have a company in NMN Bio, which produces nicotinamide mononucleotide supplement, and you've got a whole range of other stuff coming as well. Why did you decide like you need to get this out there on the market, based on your research and your knowledge around this area? Why is it important that people take NMN if they're serious about slowing aging?
So first of all, I came across the biology of NAD and NMN during my PhD studies, and my research kind of led me into this field because I was studying autophagy, neurodegeneration, and actually I still cannot disclose my my research data.
It's not published.
My paper from my PhD is not published yet, but hopefully soon. So we're about to submit it quite soon, actually. So for this reason, I started studying the biology of NAD, and I actually saw how important and how crucial NAD is to the cell, and what happens when we have a lack of NAD and depletion of NAD pools in the cell. And I've been supplementing with different kinds of vitamins and supplements my whole life, really.
Yeah.
So I was watching closely this space for a while, and I was taking different supplements myself for a while. And so when I came across NMN, and I realized that actually there is this strategy where we can supplement with a precursor in order to increase our NAD levels, I found it really, really interesting. And I thought to, give it a go myself and try it out and see the results. And then what struck me was that the immediate effect of the supplement. So within a few days, you can already feel a difference in your energy levels and your focus. And this comes from the fact that sirtuins are responsible for so many molecular processes in the cell. And this is why you have this effect, including the mitochondrial biogenesis, which is which gives you basically increased ATP consequently, and then
so you get actually more mitochondria. So like if you've got heart disease,
production of more mitochondria, and then they produce more ATP as a result, and then you have this effect of increased energy. Yeah, so this is why I thought to bring this product into the market. And the other reason was that there was not enough reliable suppliers on the market, which is crazy because it's actually quite a popular supplement. It's been on the rise. The interest was rising for the past couple of years, but what we're seeing is there is a lot of white labeling companies that don't offer any certificates of analysis and so on. And also you have even big companies not offering proper certificates of analysis, which was it was so amusing to me. Like, I don't understand. You have a big company and you have just a purity report from like 18 months ago, and you don't have any other analysis such as heavy metals or pH or microorganisms. So the consumer is actually not confident in buying from you. And I wanted the best quality for myself and my family. And then I said, wait a minute, so this is not done right. And this is why I launched the company, because I wanted a company that was completely transparent. And I even say it on the website that if you're interested in finding out who our suppliers are and so on, and have any questions about our supply chain, just feel free to reach out to me, and I would be happy to disclose all of those things. Because there are other companies that you can't find any registration number or who the founder is and so on, and it's quite confusing really, because like you don't know who you deal with.
It's the same with the whole supplement industry, and this is on the one hand, it's good that it's not regulated by the FDA and whoever else. There are authorities around the world, because like then it'd turn into the pharmaceutical industry, which don't get me started. But but on the other hand, there's not enough regulation around the quality control. And one of the things when I was searching for NMN, searching the world for it, I had to go overseas and import it to friends in America and get it out of there. And this is why I was super excited to discover your work. And then we've since now made it available down here. So we're going to branch down here in New Zealand for New Zealand, Australia. And I wanted someone who I could trust, who has all the scientific knowledge behind it. It's all lab tested, etc. And that was really important for me for quality. Just on a side note, so I've been taking NMN now for, I think, 5, close to 6 months. I've had a massive weight loss, and so has my mum. Why would that be? I didn't take it for weight loss. I wasn't overweight per se, but I had a couple of kilos that I was quite glad to get rid of. And I've noticed, because I'm an athlete, that's my background. I haven't lost an ounce of muscle, which has been really awesome, because most people are struggling to keep muscle mass, lose fat mass. My mum has lost 11 kilos, and she is of a genetic body type that really struggles with weight loss. She's a conservation metabolism. From a genetic point of view, very, very hard for her to lose weight. So I've never seen this in the history of her entire life, since I've been around, that the weight's just dropped off her. Is there some sort of upregulation in the metabolic pathways? Is it improving the insulin resistance? What's it doing there to cause such weight loss without muscle loss?
Well, in my studies so far, there is definitely evidence that it does improve insulin sensitivity, and it also improves the lipid metabolism profile. So those two are very important. And unfortunately, we don't have those studies in humans yet, but more clinical studies are on the way, and hopefully we'll have very good results this year with the NMN, besides the safety studies that we already have in humans. So in mice, what we're seeing is that there is basically a reverse of type 2 diabetes. Wow. Which is really impressive. And if you want to correlate this data into humans somehow, I would say that obviously I'm not a medical doctor and this is not a medical advice, but I would say that it does have to do something with the metabolism, and it basically improves the way your body metabolizes everything. And
worth trying, and there's no downside to NMN, is there? There's no. It's a vitamin B derivative. Although people have said to me, "Well, can't I just take B3 and be done?" And it's like, no, it doesn't work like that. I wish it'd be a heck of a lot cheaper.
That's the other impressive thing about this compound, is that it actually doesn't have any side effects at all. So even in studies with mice where the dosage that they use in mice is actually much higher than it is in the one that we're usually having in humans. So for instance, if someone would take 500 mg or 1 gram of NMN per day in humans, and then in my studies, they use something like 200 mg per kilogram of weight, which is much, much more. And it still doesn't have any side effects.
Well, so, is that then, do we need higher dosages of it then, like in the human, or is it only been tested to 1 gram? And why has it not been tested higher, if that's the case?
No, I think that there are studies underway for this as well. So eventually we will find what is the ideal dosage for humans. I think that from anecdotal evidence, people can already see results from 500 mg or 1 gram and so on. There are people that take more. So, some biohackers say that they take 2 grams or 4 grams, and it's still very well tolerated. But so far it's definitely, it does not produce any side effects in terms of
any downside,
basically. And for instance, for myself, my stomach is quite sensitive. So when I'm on an empty stomach, I can't take vitamin C or caffeine, and I get nauseous and so on. And this is not the case with NMN. So I can take it first thing in the morning, and it's very well tolerated on an empty stomach, very mild. I really love it. There's so many ways to love it.
Yeah. I have my morning and night. So I'm on a gram a day. And I have, is there any reason not to take it at night? So I split the dose, thinking,
I would,
keeping the
I would,
levels up.
yeah, I mean, I would probably take it all in the morning. I think that there's been a study out that it can affect the circadian rhythms as well. And interestingly, it actually affects NAD levels affect the circadian rhythm, but it's
Yeah.
not the other way around. So NAD actually dictates the circadian rhythm
Wow.
in the body. So for this reason, I would suggest to take it in the morning, because then your whole body is synchronized, and you wake up and you tell to your body that, look, it's the morning now, and we're gonna have increased NAD levels.
Increase. Oh, okay. So,
Yeah.
okay, I got that wrong. I haven't noticed that I've had worse sleep or anything like that, or that my circadian rhythm's been out. But I will definitely swap to doing it. My thinking process around that was keeping the tissues saturated, over a 24-hour period, as opposed to all at once and then it perhaps dropping. But I don't know, what is the half-life of it? Do you know? Is there any sort of evidence around that?
I actually not sure.
There's nothing. There's no evidence yet. And so there's a ton of studies still being done that are currently, like this year, like going to be coming out, which is going to be really exciting. So that we're going to get more evidence. I mean, there's stuff that I've been reading around fertility in animal studies, and they're starting to do human studies, which I personally am very interested in. And reversing aging of the ovaries, and even with I mean, the mice study was incredible around fertility, where the mice were postmenopausal. They actually knocked off any existing eggs with chemotherapy, then gave them N, and the mice went on to have babies. And I believe there was a horse study.
This is why I got so excited about NMN, and this is why it's my first product, because frankly speaking, as a scientist, I've never seen results like that with a natural compound.
No,
because there is a bunch of natural compounds out there. There is a bunch of other supplements, and we were talking about spermidine the other day.
And another very interesting,
another autophagy activator. Quite an interesting supplement, yes. By the way, it's also an mTOR independent autophagy activator, which is good.
Another very good reason to take that as well. And we're looking into that, aren't we, Elena, about adding that?
To the
we
will look into this, but again, it's not like you can't, you don't see results like the ones that you see with NMN in multiple studies from other compounds. It's really fascinating.
Wow. So so there are other products that are going to, and this is a super exciting thing, like where our grandparents or our parents even didn't get the chance, with aging was aging, and there was nothing that you really could do to influence how fast you aged. That they weren't aware of it, and later on it's become, if you eat better and you exercise a little bit more and you stop smoking and stuff, you'll age slower. But now we're taking exponential leaps in our knowledge. I mean, I fell into this realm when I was reading Dr. David Sinclair's book, who's a very prominent scientist at Harvard Medical School, and read his book Lifespan, which I totally recommend people reading. I was just like, oh my gosh, if I can stay healthy now, because I'm 52, if I can stay really, in top shape for another 10 years, by then we're going to have stuff that will help me live really long. Exactly. And that really excites me. And not just live long, but live healthier. So that
because that's the important part. The important part is not to just increase your age, is to increase your health span. Absolutely. So the time that you're spending being healthy. And what you're referring to is actually called the aging escape velocity, where we'll have more advanced research coming in every year of our lives, and this will eventually expand our lifespan, which is amazing. And I also think that if we preserve ourselves well, we might as well see this in our lifetimes, which will be amazing.
Absolutely. And, I want another few decades, please, listening to Dave Asprey, who we, both
I want
love.
another like few hundreds.
Yeah. Well, hey, I mean, I know it sounds ridiculous right now but if you listen to like Dave Asprey saying conservatively, and Dr. David Sinclair too, like conservatively, we could live to 150, 180 and beyond. And once they crack the code and they're actually able to turn the cells back to their, which they are working on right now, and which they can actually do in the petri dish, from what I understand, like with skin cells, and make them immortal. And they can't yet do it in humans because it's too risky. They could turn you into a tumor and stuff. But with the Yamanaka factors that were discovered a decade or so ago, they're actually able to turn the clock back to the point of you being a 20-year-old again. And this is like, wow, this is pretty exciting. Being able to regrow nerves, spinal injuries, people who've gone blind from macular degeneration, all of these things are coming down the line, and this is really, really exciting.
There are several advancements in this field. So as I said, my PhD is also in stem cell biology. So I was working with human embryonic stem cells in the lab. Wow. And what they can do on a dish is just mind-blowing, because what I was able to do was to take human embryonic stem cells and then dictate their fate basically with different growth factors, and then differentiate them into neural precursors at first, and then to push them further in order to become terminally differentiated neurons. And then, like 4 weeks later, you basically have a human brain on a dish, and it's a primary human cells. And it's an amazing physiologically relevant human platform as well to study disease. And this is what I was doing during my PhD. So I've seen it with my own eyes. And, every time I would go through this process, I would differentiate the human embryonic stem cells into neurons. It would be as exciting as the first time, because of what it represents, because it does represent the progress that we've made so far. And I personally studied human embryonic stem cells for the sake of drug discovery. So I wasn't interested, my project was not focusing on different therapeutic applications. However, I know that there are many advancements in this field as well. So we do have clinics in America where you can have, a total, total body rejuvenation.
Stem cell replacement.
Stem cells, and so on. And, this technology is definitely advancing. And I've been actually thinking about the application of this for myself. So as you know, I recently had a dental injury, and this is something to keep in mind for the future. So perhaps in the near future, I can just inject myself with a bit of a stem cells there, and close
and that's already happening to a degree. I mean, I've got a doctor friend up north who's doing stem cell replacement for joints and so on, for degenerative joints, and because stem cells, basically, for people who don't understand why this is important, the stem cell is the original cell before it decides, am I going to become a skin cell or a neuron or a liver cell, and differentiates. So it's a pluripotent stem cell. It can become anything. And so in the lab setting, you're going to be able to say, well, I want you cell to become a liver cell. Will we eventually be able then to grow organs that can be used for transplantation? Is that sort of one of the end goals?
Absolutely. And, it's already been done with some organs. So for instance, I've heard that there is a research group that basically 3D printed a functional thyroid gland from stem cells, which is,
wow. 3D printed.
Yeah.
So the printer gets these differentiated cells somehow, and then makes it into a functioning organ that they're going to be able to actually transplant this into people and save the whole organ donation horrific troubles that we have currently.
Yeah, exactly. And I think that, we're not too far away from this, from whole organs being, recreated in the lab. We already are able to actually do 3D culture in the lab and create the so-called organoids. So for instance, from stem cells, you can do a brain organoid where you have a little sphere, and it basically consists of, of different kind of cells that you see in the brain. So it would have neurons, it would have glia, it would have astrocytes, and then you would have this brain organoid, and then you can study it. So, we're already getting there. We're close, we're much closer than we thought we would 20 years ago. And, I think that, we're not far away from having different kinds of organs being grown in the lab for transplants and so on.
Hopefully not our brains, because we want to the seat of who we are and where our, it gets a bit like, honestly, reading Dr. Sinclair's book, I was like, am I in a Star Trek movie or something? Because it is pretty amazing. But when you do this, you also start to understand the whole process and how the whole thing functions, and then you can actually, already slow down neurodegeneration and optimize things. And so the NMN that we're talking about right now is the beginning of this really exciting road, at which, we're going to be staying abreast of and hopefully adding to what we have available to the consumer right now for prices that are not moon money, that it's out of anybody's reach, but actually what you can do today so that you can preserve your health, so that in 10 years' time, when the real crazy stuff starts coming online, you'll be able to live longer and healthier lives. That's the whole goal of it. So can you just, before we just wrap up, I just wanted to reiterate again. So how is autophagy, can you just put that, how is autophagy related to NAD and the sirtuin genes? Can you just put that two pieces together again and just repeat that a little bit?
Sure. So basically what happens is that you do need autophagy to recycle different damaged organelles in the cell when something goes wrong. So, and this is quite prominent in neurodegeneration, because the reason we have, let's say, aggregate-prone proteins in neurons and dysfunctional mitochondria and so on is because neurons are terminally differentiated cells. This means that they don't divide anymore. So they rely on autophagy in order to for their housekeeping function, because they can't divide the junk away. Okay. So that's the reason why autophagy is important in terminally differentiated cells such as neurons.
So neurons don't differentiate. So they don't. So there's no Hayflick limit for a neuron. There is just only one. When a neuron becomes a neuron, that's a neuron. Okay.
Yeah, and then that's it. And what happens with the activation of autophagy? One of the signals is comes through sirtuin 1, which basically can activate the transcription factors that are related to autophagy activation, which is the TFAP transcription factor EB and FOXO, which are basically influence the activation of autophagy, and more specifically the mitophagy as well. So mitophagy is the arm of autophagy that is responsible for the mitochondrial clearance in the cell.
Yep. So mitochondria, just for people, are the powerhouses of the cell. This is where a lot of all of the energy is produced, if you like. And so this is why mitophagy as opposed to autophagy. So mitophagy is doing the same process, but within the mitochondria to keep your mitochondria healthy. And if your mitochondria are not healthy and they're dying and you're not having enough mitochondria in your cells, then you are going to be sick. And that could be heart disease, that could be neurodegeneration, that could be anything. So keeping your mitochondria healthy is the basis of all bloody disease, to put it blatantly.
Yeah, exactly. So then if you have impaired autophagy in the cell, and then you also have some sort of a DNA damage going on, such as the one from reactive oxygen species, for example, then what you'll have is the activation of the PARP enzymes. And PARP enzymes heavily rely on NAD levels in the cell in order to function. And NAD is also a substrate for the sirtuin genes that are responsible for also regulating a bunch of very healthy, a bunch of processes in the healthy cell. And for this reason, if you do have increased activation of PARPs, you will eventually get this NAD drain out of the cell, and this will not be enough in order for the sirtuins to function properly, and this will also deplete your autophagy. So both NAD levels and autophagy are important to the cell, and fortunately for us, we can actually replenish the levels of NAD by supplementing with NAD precursors such as NMN.
Okay, and so NMN has been proven to be bioavailable, because there's also like nicotinamide riboside, which is used in a number of supplement companies that I know have nicotinamide riboside, but not many. There are some now, but have nicotinamide mononucleotide. And nicotinamide riboside is also a great molecule, but it's 2 steps away from becoming NAD.
Yeah, so
available.
Nicotinamide riboside needs to be phosphorylated and thus converted to nicotinamide mononucleotide first, and then this will enter the cell, and then this will increase the levels of NAD in the cell. And for this reason, so first, this area of research was focusing on the NR molecule, the nicotinamide riboside, but then when they started studying NMN, they actually saw that there is increased bioavailability, and there is increased levels of NAD that come after supplementation with NMN.
Can you take, because NAD is a molecule, you cannot just take it as a capsule and then it's all good to go. Can you take it as an infusion? Because I have heard of NAD infusions. Is that, I mean, it's not available here, but
well, and I'm curious myself about this, and I haven't done it, I haven't tested it, and from what I've seen, so the concentration of NAD in those intravenous injections is quite low. And I think that, the same way that we have many opportunistic companies in the supplement field, we also have many opportunistic clinics that offer this kind of treatments. So again, this is not something that I have studied in depth, and I actually don't know how well it
will be, how available it will be.
Yeah, how much will it help? But yeah, I mean, this is another way to boost NAD, I guess, and we can try it out. But with oral administration of NMN, we do have evidence that it can boost the levels of NAD in the tissue and in liver tissue and muscle tissue and so on. And also, it's much easier to do, and it's obviously much cheaper because those injections cost a lot.
Yes, yeah. Just one last question in relation to antioxidants, because, I mean, 10 years ago or so, we used to think, reactive oxygen species, oxidative stress happens when, through the electron transport chain when we're metabolizing and so on. We get all these oxidative stresses and free radicals running around. And if we take antioxidants, we're going to be counterbalancing that. Just supplementing with antioxidants like vitamin E, like glutathione, like vitamin C, and so on, alpha lipoic acid, is that going to contribute to the slowing of aging because it's going to downregulate the PARP enzymes?
So people were very optimistic about antioxidants, something like 20 years ago.
Yeah.
And everyone was talking about it and so on. But actually, the big studies that have been done have shown that by taking antioxidants, you actually do not suppress aging. And, there are some biomarkers that might have changed in those studies, but most of the biomarkers that they measure stay the same. Basically saying that, antioxidants is not the
holy grail
aging that everyone was thinking of.
Hoping, yeah. Not to say that antioxidants don't have their place, because they definitely do, especially if you have a lot of oxidative stress and you need to, like with vitamin C, if you're infected, or, I've done a whole series on vitamin C, but that it's not the holy grail for stopping the aging process, but it probably does help with, not having so much PARP activation. I don't know, as a non-scientific brain, I'm just connecting dots. Okay, so I think that's probably so from a lifestyle intervention, apart from taking NMN and resveratrol and oleic acid or olive oil, and intermittent fasting, Is there anything else that we can add to our anti-aging regime on a lifestyle intervention side?
Intermittent fasting, and then avoid exposure to sunlight, as we said, and sirtuins are being activated from any kind of stress. And what we can do is we can also induce some sort of an artificial stress, which could be done, let's say, with cryotherapy. This is what cryotherapy does. When you're exposed to cold, you also have this the stress signal that activates sirtuins, or the other way around. So you can try out a sauna. And this will also have the same effect. So I think this is also something to keep in mind.
Then breathing. So, sort of tumor breathing, or, like what Wim Hof does, all of that sort of stuff. So these hermetic stresses, these exercise, obviously, that cause a cascade of changes and make you stronger. And it's sort of a balancing act. You don't want to be doing exercise for Africa or really freezing yourself to death, but you just want to have a little stress to cause a change in the body. So these hermetic stresses can be very, very helpful. Okay, well, I think we've covered a very, very, very complex topic, and I hope we didn't lose everybody on the way. But at the end of the day, take NMN, take resveratrol, take olive oil, do your exercise, get in the sauna. If you have a chance for cold therapy, do that as well. Get your exercise, get your antioxidants in there as well. To a certain degree, and you're going to be able to live long enough until other things come online, and you'll be able to improve everything.
Sounds good.
Brilliant. So, Dr. Elena, thank you very much. Dr. Elena's been on the show, NMN Bio. So we have nmnbio.co.uk in the UK and in Europe, and nmnbio.nz. If you're down this end of the world, we'd love to help you over there. If you've got any other questions, please reach out to us. And thanks very much for being here today. It's been really exciting.
Thank you, Lisa. Thank you so much for having me.